Hello, everyone. Welcome. Thank you for taking the time out of your day to join us for today's presentation. My name's Kayla. I'm here from the Acelab team, and we have Michelle and our maid from the Safety First team, where they're going to be guiding us through today's presentation. But before we jump into that, and while I'm letting everyone trickle in, I want to quickly show everyone where you can learn more about Safety First on Acelab. All right, so you should be able to see my screen now. We're looking at their brand page, so you can check this out. You have direct contact information here if you'd like. Got some great value propositions as well as a full scope of their products here for you to explore. You're welcome today after the presentation to click into any one of these to learn a little bit more about them. You can also save each of these to your firm library for future reference if you'd like. So definitely check out their page when you get the chance. And I will drop a link to this in the chat. We've got some case studies here as well to explore. But before I pass it over to Michelle, I want to make sure everyone knows that this is an AIA accredited course. We collected your numbers upon registration, so you should already be good to go with that. If you're concerned that we didn't get your number, you can fill out the form that I'll be dropping in the chat to ensure that you get credit. So look out for that. We will also be doing Q&A today. So if you have any questions that pop up, feel free to drop them in the Q&A button that you see at the very bottom of your screen. We'll get to those towards the end. We will also do a poll, so you'll see that pop up during the presentation. If you're interested in getting more information from the Safety First team after today's presentation, fill out that poll and we will be in touch. And then we also will do a post-webinar survey. So definitely encourage you to participate in all of those. And without further ado, I'll pass it back to Michelle.
Great. Thank you so much. Let me know when everybody's looking at your screen, at my screen.
I
Yes?
can see it. Yes.
Perfect. Okay. Well, we are going to talk today innovative design applications using advanced fire-rated glazing technology. And I guess I should have introduced myself a little bit. My name's Michelle Murray, and I'm the architectural sales rep here at Safety. And I work on the front end of projects to get them specified into projects. As Kayla mentioned, this is an AIA accredited presentation. So moving forward, I will keep it generic to the best of my ability. Sometimes a we or us comes in and it's not intentional. This is a copywritten presentation. If you would like this presentation, we can get that to you. You just send us an email and we're happy to share that with you. So today we have 4 learning objectives. We're going to look at the history of fire-rated glass from kind of where it started to where it is today. We're going to look at the differences between fire protective and fire resistive glazing and how the IBC distinguishes them. And if there's any takeaway from the presentation, I think it's objective too, and it's very, very simple once you understand the differences. We're going to look at how the architectural community's demand for larger sizes, better clarity, kind of have shaped fire-rated glazing product development over the years. And then finally, looking at the importance of a multifunctional fire-resistive glazing, meaning it's a fire-rated glazing first, but then there's another functional performance feature that needs to be incorporated into it. But first, let's look at the history of fire-rated glass. The old solution was basically no view. So the opening would be covered up with some sort of fire-rated material. Wire glass and ceramics started to come into play, and they were used in small door lights and openings. When wire glass or ceramics are used in these doors and side lights, there is that possibility of breakage. And so a safety standard was established in 1977 to protect people from injuries from wire glass or ceramic. And those locations need to be filmed or laminated. two categories were established. You have CPSC 16, CFR 1201 Category 1, and that means that the glazing needs to meet the impact of basically a small child running into it, 150 foot-pounds. If the opening is larger than 1,296 square inches, then it's category 2 and needs to meet the impact of an adult, so 400 foot-pounds running into it. As we look at the evolution, on the left, you'll see where this laminated ceramic is a little bit of the older technology. You have clear specialty fire protective glazing, which is a much clearer solution. Even in the clear, transparent fire resistive glazing and the larger sizes. We're going to look again at the evolution of fire-rated glazing. So you have multifunctional, meaning a fire-rated product first, and then adding some other functionality to it. So where can fire-rated glass be found? You're probably used to seeing it in fire doors and openings in windows, so vision panels, side lights, transoms. Maybe not so much in the fire-resistive barrier where it's actually considered a wall assembly. And then finally in fire-resistive floors, which can be non-load bearing and load bearing. So our next objective, like I mentioned before, this is kind of the meat of the presentation, is understanding the differences between fire protective and fire resistive glazing. The IBC has two standards, fire protective and fire resistive. On the left, you'll see fire protective, which is basically openings, windows, or doors, and then fire resistive, which are considered walls. They are not the same, and we'll go into that. For a door, side light, transom, a fire protective opening is typically 45 minutes and less, and it contains flame and smoke. When you get above 45 minutes, it becomes a fire resistive wall, and that contains flame, smoke, and blocks the radiant heat. So those are the key differences, is that they both contain flame and smoke, but a fire resistive assembly is considered a wall and must block that radiant heat. So how does a piece of fire rated glass get its rating? So first, it's going to go through a fire endurance test. So this is going to determine how long that glazing can withstand a fire and heat. If the glass remains in the frame with no openings and limits the flame, it's certified anywhere from 20 minutes to 3 hours. Now, a fire resistance rated piece of glazing must also limit the temperature rise to an average of 250 degrees or less. So again, this is just the fire endurance test. It needs to stay in that opening from 20 minutes to 3 hours. In the US, we have what's called the hose stream test. And after the fire endurance test is completed, that same test specimen has water delivered to it via a hose stream. And it's a predetermined distance of 20 feet and a predetermined pressure of 30 psi. The standards of ASTM E119 and UL 263, you cannot have any glazing loss. For NFPA 257, you're allowed a 30% separation of glazing around the perimeter and a 5% loss at the center. In the US and Canada, all fire-rated glazing above 20 minutes require a hose stream test.
Michelle, are you still there?
Yep, I'm here, sorry.
Okay.
Yeah, sorry. I thought there was another video on that. My apologies. The radiant heat. So what is radiant heat? It's invisible electromagnetic waves that travel through the air, and typically they're not impinged by anything. But if they hit an object and that object happens to be combustible, it can create a fire. It can ignite. This is a radiant heat comparative test. Now, these are showing products that are fire protective. And this test isn't to show failure, it's just to show how quickly spontaneous ignition can occur if radiant heat isn't blocked in a fire. Now, in comparison, this is a fire resistive assembly. So not only is it containing that flame and smoke, it is also blocking the radiant heat. So what you're looking at there is the activation of the inner layer of the product that is absorbing the heat containing that smoke and flame as well. And it's showing that the ability to touch the glass. So a fire-resistive glazing is defined as meeting the fire endurance test, the radiant heat test, and the hose stream test. So again, the only difference between that and a fire protective is meeting that radiant heat test. So on the market today, there are two types of products that meet this fire resistive requirements. On the left, you'll see a semi-solid fire retardant between two pieces of clear tempered glazing. And then on the right, you'll see a multi-laminate, which is layers of annealed glass. And in between those layers of glass, you'll also have an intumescent fire retardant. So they both meet the same functionality of being a fire resistive product. It's just a manufacturing difference. So this is an example of how the fire resistive glazing works. The glass is exposed to the fire. The fire retardant turns into a char. So it's an intumescent layer. And once it's activated, the moisture is sucked out of that inner layer and it becomes that blocking char. The glass temperature remains low and the radiant heat is blocked. To be considered a fire resistive assembly, you also need to have a fire resistive frame. So again, keeping the unexposed side at less than 250 degrees. You'll see on the right of the exposed side, this slide shows a little bit more clarity on how the glazing works by design. The side of the glass that is facing the fire breaks by design, activating that interlayer, and that becomes that fire heat absorbing char. So again, for everything to be considered an assembly, it needs to be glass and frames. Our next objective is we're going to looking at the demand for larger sizes, better clarity, and then unobstructed views and thermal performance. Now you can get much larger sizes in fire-rated glazing. We have a couple of case studies showing some large size glazing products. This is a historic manufacturing building, and it's in New York. The 3-story glass and steel addition was added onto a 4-story brick warehouse. Having clear views to the landmarks such as the Statue of Liberty and Empire State Building was of utmost importance. Proximity lot lines mandated 2-hour fire resistive requirements. At the time of the installation, these panels at 11 feet high, 5 feet wide, were the largest installed in the US. Low iron glazing is incorporated and a high performance energy efficient low E. This is the Starbucks Reserve Roastery in Chicago, Illinois. This is the largest Starbucks in the world. It's the sixth Starbucks reserved globally and the last one. The space used to be a Crate and Barrel flagship store, and it features a 4-story mural by a Chicago artist, and it's located in a 2-hour stairwell to allow the mural to be visible through multiple floors. 2-hour fire-resistive glazing and a butt joint application were used. Each panel is over 10 feet high and over 4 feet wide. The doors are 10-foot, 90-minute temperature rise doors. No transom is needed. And this allows the glazing to exceed the 100 square inch vision area. We're going to look at some optical clarity projects. This is incorporating low iron glazing. This is the Harvard School Business Klarman Hall. This is a state-of-the-art 1,000-seat auditorium and gathering space. The facility wanted to be able to not only have performances in here, but they wanted to be able to do fundraising and have a connection between the lobby and the auditorium. This is a 2-hour glass wall, 90-minute doors. The 2-hour fire-resistive glazing used low iron for a visible light transmission of almost 90%. The glass walls were segmented in plan, has a 2.5-inch profile to mimic the look of an aluminum storefront. And those were 9-foot, 90-minute doors. And this is a couple of butt joint applications. This is the University of Wisconsin School of Business Learning Commons. Typical stairwells are dark and tucked away in the building. The university wanted to reimagine this, and this 1-hour stairwell is transparent, centrally located, and ideal for everyday use. The clear butt joint fire-resistive walls provided ultimate transparency while meeting the code requirements. The doors are 9-foot, 60-minute temperature rise, and were used to eliminate transom and again to exceed that 100 square inch max in the door vision area. 60-minute fire-resistive glazing was used. This is the Waste Management headquarters in Houston, Texas. This is a 2-hour stairwell, which is the focal point of their facility. It's a 9-story living wall that Waste Management has. Ultra low iron glazing was used for maximum clarity and again, a clear butt joint. The panels are 9 feet high, 4 foot wide. This is a fun project. This is the Porsche Design Tower in Southern Florida. This is a project that features 3 fully automated car elevators that take residents from the garage up to their units where they have a sky garage. The elevator shaft enclosures are required to meet fire rated requirements to ensure transparency, and interior segmented fire-resistive curtain wall was used. Residents remain in their car and enjoy oceanfront views as they ascend to their units. This is a 60-story residential project. And they're right now looking at where the cars will be parked in that sky garage to maintain transparency and meet the fire rated requirements between the sky garage and the living space. Fire resistive glazing and framing was used for the 130 units. And we're going to look at some thermal performance where we incorporate high performance glazing for energy efficiency, but also for fire rating. This is the Aspen Art Museum. This was built in 2014. It's a woven wooden screen that encloses the curtain wall. Sections of the glass curtain wall also function as elevator enclosures, so it had to meet the fire resistive wall criteria for 2 hours. As it's exterior and exposed to the elements, it needed to be able to perform in extreme climates, just as the non-rated areas were. The 2-hour fire resistive curtain wall incorporates high performance energy efficiency glazing. Thermal analysis was performed on the 2-hour fire resistive curtain wall to ensure that it insulated, as well as the non-rated areas, and dynamic curtain wall testing, thermal cycling, and condensation evaluation were also performed. This is the Cortland in New York City. This was a renovation project where, due to lot line proximity, one side of the building needed to be fire rated, but also meet energy efficiency. Another situation came up where, when this project went time for award, they were notified that they were not able to install scaffolding on the exterior of this building. So all of the fire rated units were installed from the inside. It was important also that because it's a renovation, that the facade maintain consistency on the non-rated as well as the fire rated sides. And we're going to look at the demand for the multifunctional, where it's fire rated first and some other performance rating with it. This is a fire and hurricane rated project in Orlando, Florida. This is the VA Center. This is a 2-hour fire resistive hurricane rated curtain wall system. This also needed to be tested to TAS 201, which is the small and large missile standards, TAS 202, which is the uniform structural load standards, and TAS 203, which is the uniform cyclic pressure test standards. It was also important to incorporate the same high performance energy efficient glazing, kind of a reflective look on the rated areas, so it matched the non-rated areas. This project was shipped as a factory glazed modular unit for ease of installation. This is a fire and blast rated, similar to the VA Orlando. This is an Army hospital on the West Coast. The hospital was classified as a critical facility, thus additional requirements for blast hazard mitigation were required for the DoD UFC anti-terrorism standards for buildings, and ASTM F2248, the standard practice for specifying for loading a blast-resistant glazing with laminated glass. So the curtain wall, which is that canted area, needed to be 2-hour, but it also needed to be blast and fire rated. This is a fire ballistic and forced entry project in Louisiana. This is the Plaquemines Parish Detention Center. This was damaged by Hurricane Katrina and was rebuilt. The new design called for wire-free, 45-minute rated, UL level ballistic 3, and grade 2 forced entry in the control room and the corridors. The new design specified the areas To give supervisors line of sight and still providing secure separation. Fire-rated, ballistic-rated framing incorporated aluminum caps that covered all the screws, eliminating the potential of tampering with the frames. Next, we're going to look at some fire-rated floors. This is the Central Subway Station at Union Square here in San Francisco. This is a 2-hour fire-resistive floor with decorative glazing. The fire-resistive glass floor enables natural light to reach the space below, which is part of the new subway system. And it's modular top-loaded, designed for easy installation. All of our products are made in the USA. The fire-rated glass floor and structural framing meets the Buy American requirement of this product. Also incorporated inside the station are 1-hour elevator enclosures with a stainless steel clad and fire-rated floors throughout the station. And finally, we have the 21C Museum Hotel in Nashville, Tennessee. This is a 1-hour fire-resistive glass floor, has a non-slip rated low iron temper laminated glass. The design features on the second level act as a light well down to the lobby space. The floors can be 1 to 2 hour fire resistive and can be load bearing or non-load bearing. Okay, so that concludes the end of the CE presentation. Be happy to answer any questions, any comments, and I thank you for attending.
Awesome. Thank you, Michelle.
Thanks so much.
All right. Let's see here.
Let's see if I can get my screen to behave properly. It never does.
Okay, cool. So, yeah, thank you for that great presentation.
Thank you.
Folks, if you have any questions, feel free to drop those in now. We have a couple to start off with, so
Great.
let's jump in. First we have, is the clarity of the glass reduced when compared to glass that is not fire resistant?
I would say it's reduced slightly. The intumescent inner layer it's undetectable to the naked eye, but if you were to do some sort of comparative test, you probably would see a loss of visible light transmission, but it's not much.
No. All right. Next we have, when used as a floor, how far is the allowable span for different fire ratings?
You know, it just depends on whether it's load bearing or non-load bearing, and then 1 to 2 hours. So I don't know the exact dimensions of them, but I'd say 4-foot wide panels are pretty typical for a load bearing. It depends on the support. If it's a butt joint application, there's a lot of different criteria that goes into that will determine the maximum size of that panel. If they want to send an email to me, I'm happy to give them all the details about it. Again, it's going to be if it's butt joint, if it's supported, if it's bearing, load bearing or non-load bearing. There's just a lot of criteria.
Yeah, that makes sense. All right, next we have, do your products accommodate for design flexibility, for example, curves, angles, or oversized panels?
Yes, curved glass, we can do a radiused glass. We cannot do a cylindrical glass at this time. Yes, we can do oversize depending on the rating. We have up to 10,000 square inches as an oversize application. What was the other part of that question? I can do, is it curved?
Angles or oversized
Yes, we
panels.
can do angles and we can do oversize. Yes.
Got it. Thank you.
Mhm.
All right. Um, yeah, I have somebody here asking for a copy of the presentation. So we'll get you guys in touch
Yep,
afterwards to get
absolutely.
that. Perfect. And then we have somebody asking if you could explain the reason for the Aspen Museum requiring exterior rated walls.
It's because the part where it's the elevator enclosure, and by code, the elevator enclosure needs to be rated, but because it was part of the facade on the exterior, that also needed to be rated. So um if if they just enclosed the elevator with, some other fire rated material, it would still have to be rated. They just wanted to keep a consistency um to the rest of the facade.
Thank you.
Hopefully that answers the question. It's an elevator enclosure. The
Mhm.
the one area of our installation is an elevator enclosure.
Gotcha. Okay, and then we have somebody asking for if you could go over the options for color selections.
Color selections for the framing.
It doesn't say. Then
Okay.
you can provide any more detail about your question.
Okay.
Great. Um,
I mean, I can
over both.
I can start just I'm assuming they're talking about the frames of our the colors of our frames. So we have a standard color chart. Because it is an aluminum clad system, we can do anodizing, we can do mica colors. So a clear anodize and a dark bronze anodize is considered a standard. We can do black anodize, we can custom color. We do not powder coat, but we can do a custom finish to complement the rest of the non-rated areas.
Thank you.
Mhm.
All right. And next we have when a building is 3 stories taller than an adjacent building and needs to add windows, is the fire protective glass in a rated frame the best route to go for a 2-hour rating?
For a 2-hour rating, you'd actually need, there's a lot of ways to look at it because there's in a 2-hour fire resistive wall, you would need a 2-hour fire resistive glazing. There are some types of occupancies that will allow for a reduced rating based on the percentage of the wall, but that's depending on the occupancy and what it's called out. So typically a 2-hour wall is going to need a 2-hour fire resistive glazing and frame. So every project, it just depends on how the occupancy is determined.
Mhm.
So typically you wouldn't see a 45-minute fire protective opening in a 2-hour wall.
Got it.
Yeah.
All right. And then is asking where your factories are located.
So we manufacture in Merced, California, which is about an hour north of Fresno, where we only manufacture in California.
Amazing.
Yeah.
All right. Looks like that is our last question for now then.
Great.
Sweet.
Perfect.
All right. Well, if there's any other follow-up questions, feel free to drop
Okay.
that in the post-webinar survey and Michelle's team will get back to you. Yeah, any final points to make, Michelle?
No, I appreciate the time that everybody took out of their day to join the presentation. And please reach out if you have questions or if you need clarification on anything. Happy to go into detail about specific projects with you.
Oh, actually, let me launch the poll real quick before I forget. Because I think I did not do that. So you'll see a poll popping up on your screen now. So just like Michelle said, if you are looking to get in touch, get more information from their team after today's webinar, feel free to drop any details here if you have like a specific project in mind. Any additional details are extremely helpful when we're following up. Um, So I'll give everyone a couple of minutes to
Great.
check that out now. And yeah, again, if there's any other questions, feel free to drop those in the chat. It looks like some people are filling that out. Thank you, everyone,
Great.
for and I know we're a little short on time, so perfect. All right, cool. So that poll should keep going, I think, as we end
Okay.
the webinar. So
Great.
all right. Well, thank you again.
Thank
And
you for your time.
yeah, everyone, we hope you have a great day, great weekend, and we'll be in touch. Bye bye.
Bye. Thank you.